The broadcast is now starting. All attendees are in listen-only mode.
Good morning and good afternoon. Thank you for joining us today. Today's topic is new capabilities in Load Dynamics 5.4. During the presentation, all questions will be or can be asked using the GoToWebinar question panel. So please enter any questions that you have, and at the end of our webinar today, we'll go ahead and take those questions. At this time, I'm going to introduce Henry He, who's in product management, and Tim Levkowski, who's the lead engineer for Load Dynamics. So at this time, I'd like to hand it over to Henry. Thank you, Henry.
All right, thanks, Matt. Hey, everyone. Good morning and good afternoon if you're joining us from the East Coast and overseas, perhaps. All right, so pretty exciting update today. Since the last time we talked, there has been a lot of work going on here. And usually in the past, we normally just do a new release update. So as you can see on the title slide today, we're going to add in a couple of extra items here. So we're going to also do a version 6.0 sneak peek. That's a major release that our company has been working on. And that will be the next major Load Dynamics enterprise release after 5.4. So we'll show a few, not all, but a couple of key features that you're going to see in 6.0. And also, as part of the 6.0 sneak peek, we created a special 15/4/15 program. Basically, it's a beta program, and I'm going to talk more about it as we get to that slide. All right, so let's get right into it. Then, I figure I'll just take a moment to really just no more than 2 minutes to touch on the key release, new features and new releases that we did in the first half of this year, as I realized that not everyone is currently on version 5.3 of Load Dynamics Enterprise. Some of you are on versions that were released last year. So I thought it'd be good to just take a minute to talk about some of the key items that were released in the first half of this year. First and foremost, we introduced 2 series of the higher speed fabrics load generation appliances. So for a long time, we've been supporting 1 gig, 10 gig, Ethernet, and then 16 gig fiber channel. So first half of this year, we introduced the full line rate 32 gig fiber channel load generation appliance, and as well as the line rate 40 gigabit Ethernet load generation appliance. And as you can see on the chart on the right-hand side, these new appliances are delivering some very impressive performance numbers over the existing load generation appliances that we have. And the 2 appliances come in 2 configurations, a 2-port configuration and a 4-port configuration. And you compare, let's say, the 4-port load generation appliance, the 40 gig, to the 4-port 10 gig load generation appliance, you can see that you can get some extremely impressive performance out of the load generation appliances, and pretty much the same story on the fiber channel side as well. In addition to the higher speed load generation appliances that we introduced, we also added the industry's first solution to convert your production NFS v3 workload data to a workload model using Load Dynamics Enterprise. And for those of you who are familiar with that capability for fiber channel, the concept is pretty much exactly the same. It's pretty straightforward once you get that production workload data from your storage arrays that we support. All you have to do is import it and then plug it into Load Dynamics Enterprise, and we'll automatically go through the analysis and then create a workload model for you. So in first half of this year, we added support for NFS v3 to that solution. On the load generation appliance itself, we also added several pretty advanced capabilities for the existing protocols that we support. So one of them is adding NLM support for NFS v3, and the team is currently working on NSM support for NFS in conjunction with NLM for NFS v3. We also added the ability for users to automatically calculate the credits that are needed in an SMB2 test scenario, whereas before the credit setting has to be manually calculated by the user. On the HTTP/object side, we added the ability for the user to configure retry behaviors in the case that the server under test in particular returns returns a 503 error code. So quite a bit of protocol expansions as well in the first half of this year. And of course, in both TD and LDX-E, we added quite a bit of usability improvements in both products. So I realized that was pretty quick, and I just want to give everyone a quick highlight on the first half of 17 in terms of what we released across Load Dynamics. All right, so with that out of the way, I'm going to slow down a little bit and talk about the new features. LDX-E 5.4 is mainly focused on several features that really propel the NAS validation capabilities. While it's not the only area where we make product improvements, we made product improvements for iSCSI as well, and other protocols. But the primary focus for LDX-E 5.4 has been around NAS testing capabilities. So on the previous slide, I mentioned that in the first half of this year, we introduced the first solution that converts NFS v3 workload data from the storage arrays that you have in your lab that we support, and turn it and convert those workload data into workload model. What's new in LDX-E 5.4 is to add support for the ProbeNAS data. So that's a key difference. The first half of this year, it was for NetApp, some NetApp arrays and Oracle CIFS arrays. In LDX-E 5.4, we added that support for ProbeNAS. On the next slide, we'll talk a little bit more about that capability. We also added the ability for the user to specify the data content for NAS and object workloads that will yield a specific compression ratio. So that functionality has already been there for Fibre Channel and iSCSI workloads. What we did is to extend the same capability for NAS workloads and object workloads. Finally, we added DNS support for testbeds. So for a long time, you can only specify IP addresses. So now you will also be able to specify the host name when you define an IP testbed, for whether it's for NAS testing or for object testing. For SMB3 users, there's an option for you to enable SMB3 encryption. Well, the downside to that is, of course, by the nature of the technology, if you want to do a packet capture, right, using regular, the third-party solutions or test environments, you're not going to see that traffic because it's obviously encrypted. So we added some capabilities in the product that gives you a mechanism to capture these SMB3 packets before they were encrypted when you use load dynamics to do testing. So that functionality is actually going to be pretty useful for debugging purposes. So that's at a high level. Those are some of the major improvements we made for NAS testing capabilities in LDX-E 5.4. In addition, we also added several key user experience and usability improvements across the product. And we'll talk about, we'll talk more about those items as well. So let's talk about the ProbeNAS NFS v3 workload analysis capabilities that we added in LDX-E 5.4. So ProbeNAS, it's a monitoring product solution. It's an inline line rate monitoring appliance from the Virtual Wisdom product solution that we have. Now, customers who own, if you're an existing Virtual Wisdom customer, and in most cases, it will be your production network staff or production network team that will own this equipment. So if you're in a company where your production team already owns a ProbeNAS or is thinking about getting a ProbeNAS to collect and monitor your NAS environment at line rate, then what you can also do now is to take the data that is collected by ProbeNAS and then feed it into Load Dynamics Enterprise and get, number one, get a visual, intuitive characterization of what that production workload data looks like. And second, which is the most important part, click on a single button that says Create Workload. That will allow you to take that production data from ProbeNAS and convert it into an NFS v3 workload. And during the analysis process, the type of statistics, the type of analysis that you can get would be obviously the typical KPI charts, such as IOPS, throughput, and latency charts. But of course, you also want to, for the purpose of workload modeling and workload analysis, you want to get beyond KPIs, right? You want to get into reads and writes distributions. You want to understand the block size distribution, and you want to understand the metadata break down the command mixes, and so on. So those are the things that will also provide in the analysis when you take the data from when you import NFS v3 data into Load Dynamics Enterprise. And that, what I just described, is available whether it's ProbeNAS or NetApp or Oracle arrays. So from a load dynamics enterprise, we don't, we can analyze all that. Really, the key, I guess the best way to describe it is that the key difference between ProbeNAS and other arrays and is that, well, we really have no control over how granular the data is coming from other storage arrays. Some are better than the others, and I think some of you know that very well as well. So that's really the key distinction here is that sometimes if you start using this feature, sometimes say, hey, you know what? I don't see the average request size information, or I don't see the request size distribution information. I don't see the latency versus IOPS chart information. In those cases, most likely it's a result of simply it's simply due to the fact that the data coming from a particular storage array may not provide that information that we need to derive these type of important information. Whereas it's something that on the ProbeNAS side, something that we can control in-house, and we have a hardware-based inline line rate collection capability where it gives us the ability to collect as much information as possible from your environment. So I just want to make that point clear is that while Load Dynamics Enterprise 5.4 gives you the ability to interpret and analyze this data in different dimensions, at the end of the day, it really depends on the granularity and the fidelity of the workload data that your storage array collects. Okay, and while I did not plan to do a demo of this, I think I actually might just change the plan a little bit, and I'm going to run through the slides, and then if I find that we have enough time, then I'm just going to run through a demo of this as well, so you can get a better visualization of this feature, what this feature looks like, and what the capabilities are. All right, next feature, the data compression for file and object workloads. So the concept of this feature is pretty simple, and we want it to be simple. What you have here is in the screenshot, it's a NAS workload, right? You can kind of tell by some of the file system configurations up top here, right? Stuff being able to specify number of folders, number of files, and so on. So underneath data parameters, you now have an additional drop-down option that says data reduction for NAS and object workloads. This is already available for Fibre Channel and iSCSI workloads. So what we can do here is simply specify the intended compression ratio that you would like to see from your storage array. All you have to do is enter that number. We'll do the rest of the work that's necessary to generate the data content behind the scenes and send it over the wire so that your storage array should be able to look at the data content, and your data compression algorithm should be able to compress the data to achieve the specific compression ratio that you specify during the test. Now, pretty straightforward. There's to be honest, there's not a whole lot more I can talk about this functionality because this is designed in a way that's simple but yet powerful. Right? We don't want you to have to configure a bunch of complicated or complex user settings. Just specify the ratio and then let us do the work. So now with LDX-E, before LDX-E 5.4, you only have this capability for Fibre Channel iSCSI workloads. Now you have it for all workloads in Load Dynamics Enterprise. Next, DNS support in testbed. So for a long time, when you configure an IP testbed in Load Dynamics Enterprise, you have to specify. You can only specify the destination IP address of the SMB server or MFS server or iSCSI target. Anything IP-based testbed that you create, you have to specify the IP address of that destination storage array. So obviously, a pretty common case now is to use to specify a host name and rely on DNS to figure out the IP address. Now, the most common use case here is pretty straightforward and intuitive, which is the most common use for DNS for a long time, which is simply entering the host name as opposed to an IP address, right? Make it easier to remember. But certainly, when it comes to use cases like load balancing and a distributed NAS cluster, DNS can also play an important role here. So now with LDX-E 5.4, when we create a testbed, you have the ability to enter the destination address in the form of host name. And then we click on the link, the testbed link, you'll find a new DNS section in which you can specify the DNS server IP address. So this will be the server that we will query for the host, for the host name at the beginning of a workload test. And then when we get the response from the DNS server, we'll automatically substitute and use that destination IP address that we got from the DNS server to perform the actual workloads, the actual IOs. And there are some additional parameters here that you can specify, such as the DNS resolution timeout, the retry behaviors, and the time to live. It gives you some additional settings, such that if you happen to run across some issues during the test, then the test doesn't just automatically die, right? It will try to do some retries. It will give the DNS server some time to respond, and so on. And what's not included in the screenshot, but somewhere underneath here when you're actually using a product, it's also a pretty advanced capability called client caching options. In short, what that does is that in the event when the DNS server provides multiple IP addresses to a query for a single host name, well, in that case, right, we want to let you as a user tell us what you want us to do in that situation. Do you want us to always take the first IP address? Do you want us to automatically round robin rotate through the IP addresses, right, and so on? So there would be a set of client caching options that are available in the DNS testbed feature that we support. And another expansion to the NAS validation is that we added support for the original CIFS SMB 1.0 workload. So this is also a direct request of one of our customers, one of our users who I hope is on this call. And the concept of this feature is pretty simple, right? If you've been using SMB2 workload, if you've been using SMB3 workload, in fact, if you've been using any file workload, this is basically the same exact same exact concept. The only difference here is that we now can give you the option to specify CIFS SMB 1.0 as opposed to 2 or 3, right? It's the same workflow, it's the same overall design. You can specify the rewrite mixes using these sliders. You can easily specify the metadata command mixes. As you see here, you can specify the request size or block size mixes. You can configure the file system the population. How many folders do you want to create? How many subfolders per folder do you want to create? How many files do you want to create per folder? The average size or the distribution of file sizes in this file system. And of course, the data content, whether it's a bunch of, for each file, do you want to write just a bunch of zeros and incrementing some sort of hex counter? Or of course, in this case, with a new feature that I just described with the data compression, you can specify that as well, right? So pretty exciting stuff, and certainly that's not more. I mean, sorry, there's more to it, right, than what we just shown here on the screenshot and what's listed here in the bullet list. So now, if you're interested in doing CIFS and SMB work when that's your workload, as part of your testing, you will have that capability with the 5.4. All right, let's take a moment and move aside from the NAS features and talk about some of the fiber channel and other features that we added in 5.4 as well. If you're doing fiber channel testing, chances are you have enabled MPIO or have desire to enable MPIO in some form or fashion. Before LDX-E 5.4, MPIO exists, and you basically have 4 options. You can do a single port MPIO, which means one load dynamics initiator can can talk to multiple targets, right, and across multiple paths to the same target LUN. You can have a pair mode, which means you put 2 load dynamics fiber channel ports into a same MPIO group, and they're going to do load balancing to a set of to one or more target LUNs that are accessible across many paths. Same concept applies when you put in a 4-pair mode or put in all pair mode in the case you have an 8-port fiber channel appliance from us. Then we'll be able to take all 8 ports within the same MPIO group and then do load balancing to, again, the same story to a particular target LUN across many paths. So that functionality still exists. We're not removing that. one of the limitations or challenges we had in the past with that approach is that we were limited by the performance essentially hit the ceiling after you get past 4 ports in a lot of cases. So even doing an 8-port MPIO test before, you're really getting the same performance that you basically get with 4 ports. So that was really a problem. And then if you want to use all 8 ports, you had to go through some workarounds in the test bed. And in those cases, the configuration became very, very complicated, in which it was very time consuming. Long story short, so for some, actually, let me take you step back for a second. If you have already tried that yourself, I think you could, know exactly what type of user experience or usability issues I'm talking about here. If you haven't experienced this yourself in the past, if you haven't used this feature in the past, the quick takeaway is that if in older versions of Load Dynamics Enterprise, if you're doing 4 8-port fiber channel testing with MPIO, long story short is that you are not able to get the performance you need unless you spend a ton of time into configuring the workarounds. So that's the story behind LDX-E regards to fiber channel MPIO before 5.4. With 5.4, we added a couple of new options called the pairs mode, right? So essentially it's an MPIO Port Pairs option that you see in this screenshot here. In this screenshot, you see a 4 pairs mode, but there was also a 2-pair mode. Basically, what this new feature does, in a nutshell, is that it will allow you to get the maximum performance that a load generation of fiber channel load generation appliance can deliver without having to manually configure the workaround that I just described earlier a few minutes ago. In a nutshell, that's what this feature does. So before, if you were to try to use all 8 ports and trying to get maximum performance, it'll probably take you about 45 minutes to an hour, or sometimes even more, to configure the test bed correctly. Now, you simply select one of the 2 new options, either 2 pairs or 4 pairs, and we'll automatically configure the complexity behind the scenes so that you can get the maximum performance in an MPIO test without spending 45 minutes to an hour. I mean, this will probably only take you about 5 to 10 minutes now to finish configuring this complicated test bed. So the way it works behind the scenes is that when you put in the 4 pairs mode in this example, in this particular screenshot, we're going to automatically take all 8 ports of fiber channel from our fiber channel load generation appliance, divide them into 4 pairs. Each pair will have 2 ports. So basically, that's what it does. And in this particular case, since we will no longer, without getting into all the details, we'll no longer have the performance ceiling problem that I talked about earlier. And you will be able to get the max performance from the load generation fiber channel appliance when you do run these tests. And every single pass and every single port will be getting IOs. And with these 2 new options, it's ideal for maximizing the load across MPIO groups for a load balancing test. One key thing to note, if you are doing a failover test, right? And I guess one way to describe it is just a trade-off. If you put all 8 ports into a single MPIO group using the old feature or the existing functionality, and you're doing a failover test, then when one of the 8 links go down or one of the 8 paths go down, any of the other 7 paths can be used as the backup path to carry traffic across. In this new approach, because the 8 ports are divided into 4 pairs, essentially you have 4 failover groups. So let's say in this case, if the first link in MPIO pair 2 breaks, then the second link from MPIO pair 2 is the only backup link for failover testing. So in a way, this is like a trade-off, right, with this new feature. So if you're doing failover testing, then you're going to be limited by that description, by what I just described. If you're doing load balance testing, then basically there's almost no difference between this and the previous or the existing functionality in terms of feature, in terms of functionality, but certainly performance. You're going to get a maximized performance. So hopefully that this feature is a bit clear for you, and certainly I understand that it's a bit more complicated to comprehend right away. So if this is something that you don't fully get, feel free to ask questions either in this call or in an email after the webinar. All right, let's talk about some other improvements here that we made in LDX-E 5.4 as well. So for iSCSI workload, we now give you the ability to also specify some reconnect options. So let's say in the middle of an iSCSI workload test, there's some connection disruptions or some errors. Well, instead of terminating that workload, right, you now have some reconnect options where it gives the initiator a chance to, or gives you the ability to specify whether the initiator should retry the connection or just simply move on to the next connection. It also gives you the ability to specify the reconnect timers and retry intervals and such. For the data compression and deduplication ratio feature, before 5.4, we allowed the user to specify this with one decimal place. So you can say things like 4.5 to 1, right? Or 4.5 to 1, or 3.1 to 1 ratio, or 1.5 to 1 ratio. So now we added the ability to give you to allow you to specify the ratio in 2 decimal places. So now you can start to do things like 1.25 to 1. You can specify a ratio of 4.25 or 4.51 for whatever reason to 1. Right? So if you're doing testing with data reduction in any form, this would be something that should benefit your use cases. One of the, for those of you who run pre-test with a particular workload, one of the usability issues that we had in the past is that, let's say you have 2 NFS workloads. The first one is named NFS, let's make it a little simpler. The first one is named John's NFS workload. The second one is named Claire's NFS workload. And both of you enable pre-test. Well, what happens is that when you go to the results page of LDX-E, where you have a list of completed test runs, the pre-test for both runs will have the same exact name. It will just say pre-test NFS v3, right? So you have no way to differentiate or easily differentiate which pre-test is associated with which workload. So now we have automatically updated the pre-test name to follow the name of the workload that started this pre-test. So in the results page, you will now see pre-test for John's workload, and then pre-test for Claire's workload to make it a lot easier for you to identify the pre-test in the results page. For somebody who run workload suites, one of the problems in the past is that you were not able to use the same workload in the same suite multiple times. It was done that way in the past because we didn't think there was a use case for it. And however, after several customers came into this issue, and I think some of you are actually on this call as well, right, now you will be able to take the same workload and run it multiple times in the same suite. Small usability enhancement, but I think that should significantly improve your user experience around that area. And also in the fiber channel testbed, the WWID has not always been very easily readable. It's a long chain of numbers, right? For those of you who ever tried to look at it. So now we'll add some usability enhancements where it makes it a lot easier to read the WWID in the page. And there are several other usability and user experience improvements that we made in LDX-E 5.4. So in summary, LDX-E 5.4 is a major, it's a release that really focused on expanding the NAS validation capabilities, but also added some new capabilities around fiber channel MPIO testing and added several usability improvements for the product as a whole. And the release note that you get, it's going to give you a finer breakdown of all the improvements that we made in the product in 5.4. All right, so that's it for 5.4 that I wanted to share today. And now what we're going to do for the next 15 to 20 minutes or so is to do 2 things. As you remember from Matt's introduction earlier on, today it's not just me doing all the marketing guy doing all the talking. We're actually going to have Tim Yakubetsky, who's going to, he's, by the way, he's the engineer architect and team manager for DynamiX enterprise products. So, so you're going to hear from him as well in this session, where he's going to do a feature of a brand new statistics database that we built in version 6.0. Right, so you stay tuned. Please stay tuned for that. I think I only have 2 slides or so to talk. I just have 2 or 3 slides to go over for 6.0, and then I pass it over to Tim, who's going to do a live demo of that brand new statistics database that I talked to you about, that I just mentioned. So that's going to be pretty exciting. All right, the first major 6.0 feature that I want to show everyone is the iSCSI testbed tabular entry. Some of you on this call and others who may not be on this call, who have ever tried to create a testbed with 8 or more iSCSI testbeds, right, have found it to be extremely slow and difficult. And for those who have experienced that, I know you absolutely agree with me. So in 6.0, we're going to release this feature that allows you to use a table format to enter the iSCSI connection information and populate the testbed. I'll show you some screenshots and potentially maybe even switch gears and open up a browser and show you that feature. In fact, no, I am going to do that, show you the feature itself on the product. Just from some of the internal tests that I've ran, just myself creating 8 iSCSI targets in the testbed before 6.0, right? And versus 6.0, it's easily a 10-15 minute saving. If I'm trying to create a 32 target testbed before 6.0 and compare that to 6.0, it's easily a 30 or more minute time saving. If I'm trying to do more, 160 targets or 320 targets, right, or even more, if you have an even larger testbed environment, it's really hours, or you might even need to break it down across a couple of working days to get it done. So some massive time savings here with this tabular entry format. The UI is designed to be extremely simple and intuitively understand. So you can see a screenshot here. We have a testbed with 320 targets and links. Right, you're going to be, this screenshot can't even capture the entire screen. You'll be scrolling down for another, to go through another 300 links and targets to see this whole testbed. That's before 6.0. In 6.0, the same exact 320 target testbed is captured in this entire small screenshot here. All right, and the way we allow you to do that is pretty simple, where in each iSCSI service box here, you can now open it up and click on it and open a table. And in this table, it'll give you ability to easily and quickly specify a lot of iSCSI connectivity information without having to drag the mouse over and create a new link every time. Right, so here in this particular screenshot, I have 2 iSCSI services where each service has 160 targets. Right, it's pretty simple for me to just enter this information. But more importantly, we don't expect, you should not, and we don't expect you to, enter dozens or hundreds of these targets one by one in a UI either. A lot of times you can easily, in a very scalable manner, define that iSCSI connectivity information in a CSV or in a spreadsheet using Excel, which has obviously some very impressive scale and bulk edit capabilities. Right, so this iSCSI testbed tabular entry feature in 6.0 will give you the ability to import a CSV as well and populate the entire testbed. So what I'm going to do now is to go off cue a little bit and show you that feature in the product itself. So we're looking at now is the it's the current version of DynamiX Enterprise, which is before 6.0. In this 320 target testbed I told you about, this is what the testbed looks like, right? Now, if you want to actually edit it or trying to modify it, you can imagine how painful this process is going to be, right? You're going to have to come up to the edit and then wait for the page to load, and then go down to each and every single link, right? Click on one link at a time, and then redefine the IP address and redefine the target information, the IQNs, right? As you can see, it's many hours to days of work here. In 6.0, this is really what it boils down to. A single iSCSI service box, you click on the LUNs, you have the entire table here with all 320 iSCSI target information. Extremely simple for you to specify, to configure, especially if you have that information defined in a CSV. So we also have the ability for you to export, click on the export button, and get a template of what that CSV look like, right? So basically, what you do here is that you click on the export button, it downloads a CSV, and then once it downloads a CSV, what you can do is to open that CSV and then start populating that CSV with your own information. Right? You can also use the CSV to share it across team members. And when you're ready to, let's say, create a new, to create an additional set of target configuration, right? Click on this link right here, select a file to upload. In this case, what I'm going to do is to go to, let's say, one of my test beds here in the CSV information that I have defined elsewhere. Oh, sorry, wrong folder here. Right, take one of the test beds right here, and let's say we can do one of the test beds that we did with a customer here. Right, has 52 services, and then simply, oh, I think that was an outdated one. Sorry, we changed the couple of things around. Right here, here's the latest one. Right. Let's see. Oh, sorry, the other one. All right, come over here. Right, simply load that CSV in, and in 1 or 2 seconds, you now have an iSCSI test bed with 52 targets in this case, but in the other CSV, I think, in one of the CSVs, I changed we changed one of the CSV column headers. So that's why it was giving me an error down here earlier. So very quickly, you can now create within seconds, right? Well, of course, assuming that you had that CSV created in the first place, create this environment, and all you have to do is draw one link to connect to it, as opposed to 52 links. Right? In the case of 320 targets, which is actually a real customer use case from ours, right? 320 targets, you can see this, the massive time savings and the simplicity that the new feature provides. So this will be, this will be one of the major new features that you're going to be able to get in 6.0, especially if you're doing iSCSI testing. Very, very important feature that we have spent quite a bit of time on developing. So going back to the slide here, I also want to talk about earlier on the title slide, I talked about this program called 15 for 15 program. Basically, it's a feature, it's a program that we created to, number one, incentivize, but also incentivize our very own direct LDX-E users to give us some constructive feedback by trying out the feature in a way that doesn't involve upgrading or changing the current versions. And also give us the ability to thank you, really, for the time and thoughts that you're going to share with us for trying out the feature. So that's what the 15 for 15 program. Basically, the idea is that we have launched an LDX, the version 6.0 sandbox online for you to try out this. Is basically the beta program. But we're not really officially keep calling it beta program because I just want to keep it simple and informal. I don't want to sign any paperwork. I don't want to put you through your legal team with a bunch of paperwork. So basically, if you're interested, just let we'll be sending out an email after this webinar to all of you who attended. If you're interested, just reply to that, and then we'll give you the instructions. Right? Basically, I'm going to create a private account for you so that whatever you do, whatever you create, right, it's not going to be visible to the public. Right? Obviously, you want to make sure that you save the, we'll give you the instructions, but you want to make sure that you make whatever test that you create, keep it private. So simply spend 15 minutes or so to create an iSCSI test bed, using a similar iSCSI test bed that you will actually use in your own test environment, right? Because that's the whole idea behind this beta program is that we want to make sure that this new feature is going to make your real use case easier. Right, not just some random use case test bed that you're never going to use. So take about 15 minutes to create an iSCSI test bed that you would actually use in your test environment. Give us at least 4 constructive feedback, and I don't care if it's positive or negative. At the end of the day, I want you to be genuine. I want a genuine feedback, right? If this feature it's really great, well, just tell us, what you like about it. If you hate it, you know what? Be blunt, be direct. I'm perfectly okay with that. I just want your direct feedback regarding this feature because we really built this feature following some of the challenges that some of you faced, right? And after that, I'm just going to send you a $15 gift card, whether it's Amazon or Starbucks, it's your choice. Starbucks just because it's just everywhere, right? Certainly not my favorite cup of coffee, but at the end of the day, you choose whether you want it to be Amazon gift card or Starbucks gift card. So that's really the 15 for 15 program. At the end of this webinar, we'll be sent out an email, and then in one of that email will ask for your interest in the program. If you're interested, reply. If you're not interested, ignore it. And of course, if you want to give us the feedback and you don't want the gift card for some reason, that's fine too. At the end of the day, this gift card is not it's not trying to, to buy you into giving us feedback, right? Your time is way more valuable than that. Really, it's just another way for us to offer a small token of appreciation for your time and thoughts. All right, the other major feature here, and I understand I need to pass it over to Tim next for the demo, is the completed results page. What you're looking at here is the current version before 6.0, right? First of all, you're going to see that on the left-hand side here, there's a panel, the filter here that takes up a lot of important, valuable real estate space on the page. As a result, it compresses everything else on the right-hand side of the page that you actually want to look at. So in the case where you have a long workload names, well, you know what? You're not really going to be able to differentiate the difference between one and another run. And some of a couple of our customers frequently uses the description field or the notes field in the workload test to differentiate one run versus another run of the same workload name, right? However, on this page, we don't show the description field, so it makes it difficult for the user to really identify, well, really, what's the difference between these two runs? What's the difference between these two runs, and what's the difference between these two runs? Right, so overall, it's pretty compressed page, and this is before 6.0. So now what I'm going to do is move on to a screen of what it looks like in 6.0 now. So with a 6.0, this is a completely redesigned page where you can fully utilize the entire width of the page. We move all the filters from the left-hand side of the page to the top now. So you still have the same filters, but now you have the entire width of the page to work with. So that gives you additional width to space to show the workload name. Now, in the case you still have a long workload name, what you can do is click on this expand button. You can click on this individually or expand everything on the page. So the first run here where the mouse is running, circling right now, it's an expanded view of that first entry. So now once you expand it, the description now field is now shown. So when you run a workload test or you configure a workload test, you enter something in the description that says, for example, array configuration with configuration A. The next workload, same workload but a different run, configuration B. Right, same workload run but different configuration, configuration C. You can put that information in the description before you run the test, and now you will be able to see that information automatically pulled up here and shown in this page. Also give you a direct link to the test bed. That's another feedback that we have. Is that I have this one workload that I want to run to benchmark or compare 3 different vendors. The 3 different vendors are 3 different test beds, but it's really the same exact workload. So now it's very easy for you to see, which workload test run was done on which test bed. And in addition, we also added a new column here. So before you don't have the ability to, this finish on column did not exist. So now you have the new column that says finish on, and you can sort on it as well. So the completed results page now has been in 6.0. should give you much better user experience and usability, and in particular, specifically allow you to find the test run that you want to find. Now, we're not done with all the improvements here. After 6.0, we're going to do more improvements, but I think this is a pretty good improvement that you're going to see in 6.0. And lastly, this is the last part that I'm going to cover before I move on to the new statistics database for Tim. So in 6.0, we're also going to come up with a new UI theme. Right, this is going to be a new user interface. As you can see, the same homepage is now a lot more simplified. It feels a lot less cluttered. right? It's a lot more minimalist in a way. Right? You still have the same. The key thing is that it's the same workflow, right? We didn't in 6.0. We did not want to throw too many new things at you at once. We still want to maintain a workflow so that if you already have, you're already familiar with the current workflow, well, you don't have to learn a new workflow again. And really, it's a new theme, a cleaner and minimalist, and also if you're a user or the company is a user of both Virtual Wisdom product and Load Dynamics Enterprise product, you're going to see that the look and feel of these two products are going to look closer and closer together. So so that really feels like two product solutions from the same company. All right, now move on to the very last thing here, the HyperStats database. So what it is, you know what? I think you heard, I think I talked enough here. I'm going to do, Tim, is pass the control. Actually, no, I'll just have you speak, I don't know, maybe for 30 seconds right now to talk to this slide on the key bullet point, and then get to your demo. I think you're going to cover the same bullet points anyway. Go ahead, Tim, if you're able to speak.
Sure. Thanks, Henry. So my name's Tim. I'm the project lead for the LDX-E product. So for a long time, we had significant issues around performance with customers around statistics. All of our customers want to run the largest tests that they possibly can and really stress their systems under test. So in 3.0, we really in LDX-E 3.0, we really started focusing on performance and working on ways to speed up particularly statistics performance in LDX-E. That manifested in LDX-E 5.0, where we made some significant improvements as far as not dropping values during tests and supporting much longer test runs. We can currently support 16 concurrent ports in a single test running for 7 days. And the data that we capture is a data point every second. So obviously 7 days continuous run of per second data, that's a very large amount of data points. But that turns out to be not really enough. The usability of LDX-E, the LDX-E 5.0, 5.2, 5.3, 5.4 series is okay when you get up to use cases that are that large, but it's still not really real time. You still have to wait for results to show up, for charts to show up, for the summary statistics, the grid below in the screenshot that Henry's showing, and of course reporting. And really we want to make it easier for customers to look at these large data sets and really zoom into spikes or any kind of interesting areas, and also be able to really do on-the-fly analysis, both when tests are running and when they complete it. So for 6.0, we really focused on, okay, how do we achieve this? And our goal was to get 10x performance improvement, because our kind of incremental improvements just weren't being enough. And with some analysis, we kind of discovered that our best approach was to implement our own statistics database that was specifically tailored to the kinds of data that LDX-E received from the load generation appliances. It was a very kind of skunkworks internal project in BI, and we weren't sure if it was going to, if we were just reinventing the wheel or not. But it actually ended up being quite different from anything out on the market, and also very small. The actual implementation of this database didn't take very long, but it took us a long time to figure out how to actually handle this. And now I'd like to kind of show off what this approach has gained us. So Henry, if you will pass control to me.
Absolutely. All All right, Tim, you are now the presenter.
So can you guys see my screen? It should show LDX-E on it.
Yes, we can see it well.
Okay. So, so for this demo, I'm showing a test run on, this is LDX-E 5.4 right here. So this is a test run, an iSCSI test run that was done for 7 days and with 16 ports. So if I just refresh the page and have this load from scratch, you can kind of get an idea of how long this takes for the data to load once I open the chart here. This data in the grids is cached, so it's popping up instantly. But if I open this chart, you can see this spinner kind of going, and you know, it's taking many seconds for this initial graph to pop up. And it would actually be significantly worse if I had run this test without having this page open, and all the internal product caches were cold. So all of this would take minutes. Some of our customers have reported opening these long duration tests taking, 20 minutes for the data to come back, which is obviously not usable. And you can see even this, it's been probably about 10 seconds already, and the chart still hasn't opened. And this would behave the same exact way. So there it goes. So about 15 seconds to open. This would behave the same way in reporting. And for customers that want to run, 20-day tests or even longer, this would be completely unusable. So so this is really what we set out to improve. Not only that, but so the time chart is kind of our simplest form of analysis. If I were to actually try to open one of these histograms or some of the more calculation-intensive charts like latency, you can even see some of the grid stuff isn't calculating for a test this large. It would take even longer. So I will move to our XDB, so the HyperStats database that Henry was talking about. This is in a development build of 6.0. And so this is the same exact test. So it's an iSCSI test, 16 ports, 7 days. So I'm going to refresh the page. I'm going to do the exact same thing. And click on the time chart. So let's see how long this takes. And there it goes. So that is about an order of magnitude faster. It still takes a couple of seconds, but 2 or 3 seconds versus 15 is a massive difference in usability. And this improvement scales as far as the number of concurrent ports or the length of the test. Now, to be clear, so 16 ports, 7-day test, we're measuring roughly 500 to 1,000 counters per second and storing them in the database. So for a single data series, like for example, IOs attempted, that would be 9.6 million records for this test that it's pulling out of the database and aggregating. And the entire raw data set is in the old, so in our kind of previous iteration, this data set would take up 125 gigabytes on disk. Now, and 125 gigabytes, and it would be about 97 million records, each of which stores a minute of data. So just a huge amount of data. In LDX-E 6.0, one of the other benefits is because we have our own database and we know the kinds of data that we are storing and can really optimize for our own data formats. We have gained some very large storage savings as well as performance savings. This database in XCB is compressed on disk onto 17 gigabytes of space. So 125 gigs in LDX-E 5.4 is 17 gigs in LDX-E 6.0. So that's about a 7x storage savings. So our goal was an order of magnitude, and that's kind of roughly where we've gotten to. Obviously, you can still do all the same kinds of operations that you can do in LDX-E 5.4. Zoom in. You can see how much faster this is going, you know, as far as doing kind of these quick analysis situations of investigating spikes and kind of weird things in the data. And this translates across the product to reporting, iteration suites, workload suites, all of that. Same thing with histograms, for example. As I mentioned, if I hit histogram on this throughput chart, this is LDX-E 5.4 now. It might be cached, actually, so this is going to be fast on both of them. But if you were opening this cold, these histogram charts can take minutes to load in current versions of LDX-E. Let's see, is there anything else I want to mention? So yeah, that's I guess that's pretty much it for the demo. Ultimately, from a customer perspective, really what we're aiming for is, you know, kind of an order of magnitude improved usability and ability to run these extremely large tests. We are still qualifying LDX-E 6.0 as far as what it can support, but we definitely think we can kind of double at least the qualified limits for operation.
Cool. Thanks a lot, Tim. Really appreciate the demo there, and definitely very, very impressive work there from you and your team on the specifics database. And certainly, I think the two key highlights are that number one is just much faster when you're dealing with when you're dealing with a large test or long duration test, and secondly, being able to significantly reduce the amount of storage space, database space that we actually take on LDX-E. That means that, and actually a couple of customers, and interestingly enough, the email pop up while you do the demo, that it seems like we have another customer that ran into this database storage space issue with LDX-E. So clearly that would make a huge difference on that for that issue as well. All right, so we're at the end of the hour, but I do want to have some opportunity to answer maybe a couple of questions here. So if you want, Matt, can you make me the presenter, or Tim, can you make me that presenter again, and then we'll go through some Q&A.
Here, I just made you presenter.
All right, perfect. All right, and here we have an awesome Q&A slide. So Matt, go ahead.
Awesome. All right, great. Yeah, we do have a couple of questions. So let's see. The first question is, about the data compression feature, how do you guarantee that my storage will do what you say the compression ratio will be?
Okay, thanks. So, right, so obviously every single storage array have a different algorithm in place and so on. So really what we strive to do here is to come up with a data pattern that we believe should be compressible by any modern or commercial solution out there, right? Really, at the end of the day, to get into more advanced data patterns, it varies from algorithm to algorithm. So what we do is that we generate data patterns that are extremely simple, right? So for every 2 kilobytes block of data, we'll have one chunk that is completely all zeros, and then the other chunk will be a completely random 64-bit number generator that generates some sort of random number there from one octet to one octet. So these two chunks are basically what make up the data pattern that we send in the data payload. Now, how big each the zero chunk is versus the random number chunk is, that completely depends on depends on the user setting, right? If you want the some sort of let's say 1.1 ratio, right, which means no compression at all, then it's a full 64-bit random number generator at every octet. So basically making it almost impossible to have repeating or any sort of pattern associated with it. And then if you're doing the 2-to-1 ratio, then in that case, then you will have, let's say, 50% chunk of it, that would be all zeros, and then the other 50% would be some number generator. Right? So this actually not exactly 50-50, of course. So basically, that's a concept, is that in every 2K chunk of data, we'll divide the data into 2 chunks, and then the size of each chunk just depends on the compression ratio that user sets in the test configuration.
Okay, great. All right, let's see. We have another question. What do you mean by client caching options from the DNS test bed? Or can you give an example of how it works?
All right, so let me go back to that slide here. So the feature in particular, so I think this is the what I call the client caching options here. So in the case where we send a query for a host name that you specify, let's say storage target 1, that's a host name, right? And then or NFS server 1. Anyway, we send a DNS query to the DNS server for that host name. In the event that the server comes back with 5 IP addresses for that host name, well, in that case, what do we do, right? So what that does is that, number one, it really does 2 things, this client caching option feature. Number one, it gives you some control into saying, you know what, I want the client to automatically rotate through each 5 address for each new worker that I spin up in this new workload, right? So if I run this NFS workload with 10 workers, then worker 1 would use the first IP address, worker 2 would use the second IP address, worker 5 would use the 5th IP address, and worker 6 will use the first IP address, right, and so on. Give you the ability to set up, or you can say that I always want to use the first one, or randomly go through it. So it gives the client, it gives you the ability to create, to specify some customization on the client behavior. Now, more importantly, though, is that, well, if you have 1,000 client IP addresses here, right? Source, what I mean by that, the source IP address from this one load DynamiX port, and that they are going to the same server, and they're on the same subnet, then it doesn't make sense for all 1,000 client IP addresses to each contact the DNS server for an IP address, right? That would just simply overload it. But in some other cases, you may have a use case where it does make sense for different IP addresses. If you have a configuration where 10 client IP addresses on different subnets or whatnot, then that they each need to contact the DNS server for the IP address. Well, it gives you that ability to set it. So basically, the second capability, the second aspect of the feature is to allow you to define for load dynamics. Every time when I do get a host name, when I do get an IP address from the DNS server, do I apply that IP address to one client IP address only, or do I want every single client IP address that are defined on this one port to use the same DNS response, so that I don't have to overload the DNS server with hundreds or thousands of DNS queries for potentially the same thing? So those are the 2 extremes. Then we also have a third option somewhere in between. Basically, that allows you to cache the DNS server response on a per testbed link basis. So let's say you have a testbed where from one port you have 3 testbed links to the same service or different services. Then basically there will be 3 DNS queries sent out, one from an IP address, one from a client on each testbed link, and then the response that client gets will be cached for all the other clients that are on that link. Right? So in this case, in this in-between option, you will have 3 DNS queries from 3 different clients, and then the responses to these 3 clients will be applied to all the other client IP addresses that are on the same testbed link at one of the 3 clients. I hope that kind of makes sense if I describe it verbally.
Thank you. All right, we have time for, another question. Does the tabular iSCSI testbed convert my existing iSCSI testbed to that format?
Good question. So the short answer is is no or not yet. And the reason is that, as you can see in the tabular design, some of the information, in particular of the information under the testbed link, which is the client IP address definitions, some of the DNS definitions and subnet definitions, when you collapse all the tabular entry design, collapse all that into a single link. So if you have an existing testbed that have 320 links, right, as I'm showing the example here, you have an existing iSCSI testbed that has 320 links and want to convert it into something that's simple that go over 2 links. Well, we have to make some assumption that the information configured across all these testbed links can be collapsed into a single range or a single value. So, and we cannot always make that assumption, right? Because there's going to be more complications to that. So in some scenarios where we could, so basically at the end of the day, we decided that, you know what, there are 2 things we can do in the future after the, after the first release, after 6.0. One is that we can run a check to make sure that all the links here have the same configuration, have the same settings, except of course the client IP address. In that case, we'll convert it over and collapse all, 320 or 160 links in this case per port, like into a single link. That could be done. But then in the other case, we've detected that, you know what, these different links have different settings that we can't simply assume that it's safe to collapse into a single value. Then in those cases, we simply can't really do that or do that well. So it's an area where we need some thinking, where we want to do. However, essentially in 6.0, if this is really, it's a one-time configuration, right? Once you configure the tabular testbed, you don't have to touch it again. And if you really need some help with that, we're creating not quote unquote converting your existing iSCSI testbed. Then once you get 6.0, just contact us and get some help with that.
All right. Well, thank you, Henry. Thank you, Tim. If we didn't get a chance to answer your questions, we'll follow up via email. And I would like to thank everybody for taking the time to attend today. Today's presentation was recorded. We will send an email with a link to view the recording tomorrow. Have a great day. Again, thank you, Henry and Tim. Talk to you soon. Bye-bye.
All right, thanks.